Bismillahirrahmanirrahim. Now we will talk about coagulation. And coagulation is actually related to the process by the help of which the colloidal particles are destabilized, and because of this destabilization, the coagulants uh, agglomerate, and finally they settle down by the process of by gravitational forces. So this is coagulation. Before going into the detail of this coagulation, I will like to explain something about the colloids. Colloids, as you know, is existing in the dispersed form, so they are usually considered to be stable particles. So what actually their stability means, that they are going to be suspended for, and they are going to maintain their dispersed state, and thus the stability of the colloids arises from the forces which are associated with the solid and liquid interface. So every solid part, every colloid has its outer face, and that outer face is have an interaction with the liquid phase. So this makes an solid liquid interface. So this solid liquid interface is very important with reference to the stability of the colloidal particles. Because every colloid is existing in the form of some ionic form, so there is a presence of surface charge at the interface. And thus uh, the surface layer of the colloids is getting exposed to the other ionic particles which are existing within the solution. So whatsoever the kind of their interaction may be, it totally depends upon the uh, ionic strength of the colloid, as well as the distance uh, uh, between the particles. Thirdly, by depends upon the ionic strength of any specific ion, positive or negative, within the solution. So these are some things about the colloid and their stability. So as long as a colloidal particle is stable in its dispersed state within the liquid phase, it is not possible to facilitate the process of coagulation. So the important thing is to destabilize the colloidal particles. And how we can destabilize the colloidal particles, we must understand that these colloidal particles uh, consist of some charge, and then it also consists of some potential charge on it. So we must understand their strength, and we must understand how we can facilitate the process of coagulation. So now, if you check uh, one of the colloidal particles, and I will also like to emphasize that the double layer theory is very important to understand the whole process of coagulation. So I will also like to explain the double layer theory, by the help of which we can understand the whole process of this coagulation, and this surface charge, and how the intensity plays its role in the coagulation. So uh, for example, if you check here, this is a colloidal particle, and if you observe, there is a negative charge within the boundary of this charge, this colloidal particle. So that identifies that this colloidal particle is negatively charged. Now what will happen, that all the positively charged ions existing in this solution uh, beyond this phase, this plane which is exposed to the solution, all the positive charged particles will come close to this and they will form one of the uh, fixed layers. So uh, now just consider it a negatively charged particle surrounded by the positively charged ions from the solution. They will be tightly bound with this colloidal particle. Now they will be once they are tightly bound with this negatively charged colloidal particle, we will declare it as a fixed layer. So and that fixed layer will move along with this colloidal particle wherever this colloidal particle will move. So this is one concept, and at the same time their movement is normally followed by the Brownian movement. So you know Brownian movement, it is the movement of freely movement of the particles in any direction. So uh, now we have talked about the fixed layer. Fixed or stern layer. The stern layer is named after the scientist. So normally we will call it fixed layer because it is tightly bound with this colloidal particle. Is it clear? Now what next will be happening? Uh, some other charged particles will also join the that fixed layer because of the natural attraction of the positive particles with the other negative particles. So there will be a diffused layer of positive and negative. So once negative will be attracted, then those negative ions will again attract some positive, so there will be a mixture. So that a mixed form of particles will be existing in the second part adjacent to this fixed layer, and that will be declared as diffused layer. So now just imagine, I wish I could draw it. So we will be having this as a positive layer, and this is called fixed layer. So this layer is fixed layer uh, because it is having all the positive charge, and it is tightly bound with this colloidal particle negatively charged. Now for this positive charge, some negative layers will be formed here, and for this negative we will be having some positive charged particles surrounded by this. So in short, we will be having another layer surrounded by this fixed layer. So this is fixed layer, and now this is how to draw it here. So this additional layer is called diffused layer. Diffused layer. So this is fixed layer. and the other second part is diffused layer. So if you check here, another important thing, this is called shear plane, and this shear plane is actually the part which is exposed to the solution, and whole this diffused layer is loosely bound, so it is quite open to the solution. So what actually we have a very shear plane which is going to transfer the charge from this uh, mm, this colloidal particle and between this particle and the solution. So we will be having exchange of this charge and the intensity and strength. So it will be taking place on this shear plane. This is called shear plane. Okay.